Hey everyone, it's Darren. How's everyone doing?
Hey Darren, see it. Good.
And Pushkar, how do you say your name?
Hey, hi Darren. You can say that as Pushkar.
Pushkar? Like a
Yep.
short U? Pushkar. Okay, do our best here. By the way, Suji, that was I just spent a little time going through that knowledge graph stuff. It's pretty fascinating.
Yep, it is a lot of information.
Yeah, a lot of stuff happening there. I mean,
Yeah.
It's just crazy. It's crazy the relationship between knowledge graphs and ML, because you can use ML to build a knowledge graph. You could put it in your knowledge graph and embedding and do predictions on the classes and on the links. Then you could put your knowledge graph in through layers or through a loss function into your machine learning model. I mean, that's kind of cutting edge, right?
Mm-hmm.
But it's like this crazy virtuous circle eventually.
Yeah. I found one piece interesting, which I think I will try to implement. So there is a paper on BPR. It's like binary passage retrieval. So dense passage retrieval is a thing, right? So it's a neural matching kind of Siamese network, not really a Siamese. It's like a two-tower architecture with the passage encoding and the question encoding, right? They're trained simultaneously so that questions and answers are kind of comes close together in this new space. So what this guy has done is he's put in a learnable hash layer in the middle, which converts the dense vectors that are generated, the encodings for the passage and the questions. They are generated and they turn into binary. So he basically trains a sign function, right, to find the appropriate threshold at which everything below that becomes -1, everything above that becomes +1, right? So now you have a pair of binary vectors, and you can just use Hamming distance to find the similarity. So what they're doing here is a two-step thing. They are using the Hamming distance on the binary vectors to find the rough candidate passages, and then on that set of candidate passages, they are using cosine to rank them. So it's like, so you have less storage. So one of the problem is that is addressing is basically storage, because your dense vectors need to be stored somewhere, your passages, right? So he's able to bring down the storage requirements from 65 gigabytes to 2 gigabytes. Which is,
one second, you're talking about the neural DB stuff, right?
Yes. It's basically dense passage retrieval. Yeah.
It's what, dense what?
Passage retrieval, question answering, right?
Yeah. Well, it also really looks a lot like FACT,
Mm-hmm. Yeah.
Like a
facts too.
database.
Yeah.
Right. Okay.
Do you think the same?
And how are you? Go ahead, Yuri. I'm sorry.
Sure. Do you think the same technique can be used for like alignment or like entity alignment?
I think so. I mean, anywhere where you could use dense vectors, right? Some sort of similarity on dense vectors, you should be able to train a sparse, like a binarizer, and then this Hamming distance thing. Yeah, I have to, you have to look at it basically. Yeah, sorry. Yeah, sorry, Darren. Yeah.
Yuri, did you see the section of that very long post that you sent that I just put in?
Oh yeah. I started.
Did you see? But did you see they have explicitly an entity? I mean,
entity alignment.
Resolve. Yeah, no. But where they, where you actually alignment? They did graph alignment, which might be kind of your problem. Yeah. So it's sort of a.
Yeah, I'm going to look at that paper. I think it's Sun that has dangling like non-matching entities in the data set.
Yeah, they also have auto building of ontologies.
Yeah, previously I looked at a couple of papers in that field, but they seemed very different. I don't know. It didn't seem easy to use, or it didn't seem like especially relevant. But yeah, I'll definitely I opened it already. I'm going to read it next.
Yeah, I mean, and all this stuff in this blog is also cutting edge. That you're not going to just find a library with it in it.
No, but that the ontology alignment is like there's like a field that does that. There's a yearly competition, and there are people who work specifically in that field. But at least till now, what they were doing didn't seem like. At least I couldn't find anything that we could use right away.
What's the name of the field?
It's called Ontology Alignment.
Oh, okay.
Yeah, I'll send. I'll log in from the computer, and also I'll send a link to the competition.
I think we could continue talking about this stuff, but I wanted to ask Pushkar if you could, just very briefly introduce yourself and tell us sort of what your interests are in NLP, because we do cover lots of territory, and we basically let the interests of the group decide what we talk about. So, if you don't mind giving us a little bit of,
Yeah, sure. So I have been, I'm like a relatively new entrant in this field in NLP. My first kind of an introduction to NLP was on my job, where it had a task which involved doing semantic segmentation. We were basically dealing with address data, postal address data, and we wanted to do named entity recognition from addresses. That's where I got into natural language processing. I basically got interested into hidden Markov models. And that is a technique that I started off using for the purpose. This was in around 2016 types. And then slowly I have been using more recent, like embedding based approaches to look at basically to come up with deep representations of text. Recently I have been more interested in various techniques that people have come up with to come up with interesting representations of reasonably large documents. Like by that I mean like 1,000-word document on a particular topic. So I would say my broad interests are in like representational learning, and specifically so in the text domain. Generally interested in what are the kind of applications it has. So yeah, I mean.
Can you give us a little bit of your, that's great. Can you give us a little bit of your context within your current enterprise? Like what's your role? What do you spend most of your time doing? And then maybe just a little bit about, yeah, that would be good, if you don't mind.
Sure. So I can probably talk a little bit about my previous job. So in my previous job, I was working in a media and broadcasting company. It's a TV channel company actually. And there we collected a lot of data on the stories that go into TV shows. These are daily running TV shows. And over there, my job was to come up with a way to structure all that data in a way that the creative team can use. So the kind of data was, let us say you have a daily running TV show, and every day, each episode, you get about somewhere between, let's say, 500 to 1,000 words describing what happened in today's episode. So you get such kind of episodic data for about hundreds of episodes. So the task that I was working on was, can we organize this list of episodes into some kind of, can we segment it into a list of plots? Like, can we group certain episodes into those which belong to a particular part of the story and so on. That point, I got interested in learning document embeddings for each of these episodes, for daily episodes, and then exploiting that representation to segment this list of episodes into plots, basically.
When you did that, what kind of task did you try? I mean, did you do topic modeling, or did you do just a single classification class? I mean, like a single class classifier, or that sort of stuff.
So it was largely an unsupervised learning task. We did not have any labels to go with. So what we ended up doing was basically learn document embeddings, where each document represents a particular episode. And then once you have an embedding for each episode, we try to cluster it in the high dimensional space of the embedding space and see whether which episodes are appearing similar to each other and which episodes are different to each other. And then having grouped them into certain clusters, we try to see whether we are getting any meaningful clusters from it. It was more of an exploratory kind of an analysis, an open-ended study, if you will. And we got pretty interesting results over there. We found that, for instance, in one particular story, there was a particular plot which was going on about a family, like a court case was happening in the family. So all of those episodes got clustered together. And in another episode, it was about some engagement ceremony that was happening in the family. Many of those episodes got clustered together. So it was doing something sensible. Having done that, we proceeded further with using some of the extractive summarization techniques that are there. To let us say you have found a bunch of episodes on a particular track. Can we reduce the effort that a human has to take to understand what happened in that? So instead of the person having to read like 20 different episodes, just condense it down to a few lines using extractive summarization, and then can they get the gist of it? So this kind of became a product in the company, and the creatives started using that. Basically, it was more like an efficiency play at that point.
Very cool. Yeah.
Yeah, really cool. I could actually see you doing that for competitors. Like if there's a reality TV show and you could trace everyone in the industry and what the themes are.
Absolutely.
What's the most popular ones, and then we want to, we want to do something like that to compete. So that's really cool.
Absolutely. I mean, that became our singular lens on what our competitors are doing, and we could correlate that with the TV ratings, which are publicly available for even the competitors, and then you could make inferences and you could potentially make recommendations to the creative team.
Yeah, I wonder if you, I don't know, I don't think you did, but, if you had taken the time dimension into consideration, right? And see how, the episodes change over time, right? And, you could probably do that also, using your vectors. So, how much change there is over time, right? And you could
absolutely
kind of see discontinuities come up.
Yeah, probably I would like to present this, I guess, probably to this audience at some point, because me and my colleague, we are just writing up a blog article about it, describing what was the problem statement, what was the data science formulation, the methodology that we came up with, and some results. So, so far we have just put it together as a web blog, and in that we did exactly what you suggested. We lined up all the episodes in a chronological sequence, and a very interesting pattern emerges out of it, actually. So, probably I will, I think I should just talk about it at some point in this group. I'll present.
Yeah, absolutely. Looking forward. Yeah.
If you have a post, if you have your blog post that you can share.
Yes, yes,
or
we'll do that.
By the way, I did a bit of, topic modeling. There's like a BERT-based topic modeling Python library. And I used that pretty effectively. Basically, though, what it does is you choose your embedding. It's not just BERT, but you choose your embedding through transformers and embed your data, and then it actually uses map clustering. It clusters it, but it has a lot of stuff built in. Like it actually has a time-based method built in where you can actually see the topics that are generated from the topic modeling over time. It does that by comparing each time segment as you move forward and measuring differences. Anyway, it's kind of really just clustering. They call it topic modeling, and it is, but it's really just clustering all wrapped up in this nice Python library, visualization, and doing time comparison.
It's a slightly different spin, right? It goes on TF-IDF and everything. I thought it was very cool too.
Yeah, the re-ranking. I can't remember.
Yeah.
That came in. That's right. Okay. Well, look, great beginning. It sounds like you have a good, rich experience for being a beginner in NLP. Geez, I definitely not call you a beginner. But in terms of there's so much stuff to learn and do, yeah, I mean, crazy. But maybe we should give you our quick backgrounds, just briefly. So I work for a publisher called Tech Target. Built their taxonomies. I've been there about 7 years. Large IT taxonomies. Set up the manual classification system for that. We're basically an account-based marketing intent data company, and we sell that data and found it, and all that intent basically is built on top of these taxonomies. Understand who's doing what, where, what companies are interested. So that's the software vendors, and I've moved over the last 2 years into NLP, school practitioner in our company, product group. And basically, I'm exploring technologies, doing proof of concepts, and then I have a couple things. Really one main thing in production, which is where I used a word defect model to do classification on our 5,000 node taxonomy web pages that come in. So you could call that, I guess you could call that similarity. We're using a similarity engine to do classification. I'd like to move that into a supervised learning. And I've explored, basically I just try to explore NLP techniques. Yeah, that's me. I'm actually a library science person. That's my. So, about yourself, Yuri, you want to give just a quick background?
Hi. So I'm a quantitative scientist, basically data scientist at agricultural data analytics company called Grow Intelligence, and we deal with agricultural and climate data. So on the NLP side, I'm building mapping for mapping for the keys for our data sources, because we integrate a lot of agriculture and climate related data. So we bring a lot of information and integrate it into our ontology. And I do some other projects with satellite data, with more agriculture related.
Yuri, I meant to ask you
more like a.
Go push.
Yes. Go on.
No, you go ahead, please.
I just meant to ask Yuri that. So, are you doing some kind of a multimodal kind of a learning where you try to integrate image signals as well as text signals?
No, I keep like trying to look for applications for that because it's so cool. And I don't know if Sujit will talk about Clip because he worked on Clip recently. But we sort of like from what I understand, like so far I haven't found applications. So we have sort of text domain, like NLP domain, completely separate from visual domain. But the interesting thing is that the same techniques are now used everywhere. So it's sort of useful to go back and forth.
Right.
Yuri, I want to ask you a basic question I think I've never asked you. When you say your ontology of entities, right?
I don't know if it's cutting up off on my side or
No, we can't hear him either partially.
Can you hear me now? Is that better?
Yeah.
Yes.
Yeah.
So Yuri, when you say ontology, what do you guys? Is that like a knowledge graph? I mean, is it in a knowledge graph tool? What do you? Is it and also is it entities?
Sorry, I'm laughing because it's yeah. So what's the second part of the question?
Well, it was just, do you use a typical knowledge graph tool, or maybe it's in a spreadsheet, and also is it made up of like key entities mainly?
Okay, yeah. So I'm using comma separated values for our ontology. It's basically a adjacency graph that's in comma separated values. And we have like 4 or 5 parts to the ontology, and the ontology it's basically keys to our data. Key to our database consists of item, like what it is, metric on like what's being done with it, unit, frequency, and that's basically it.
So it really is it is an authority file of sorts, where that's the key that you can use to bring your data together on for each of those entities in your. Yeah. I see why you were laughing at the CSV part. Is that what you were laughing at?
Yeah, no. I was laughing at it because we actually translated it into RDF, and we're using web protege now.
You're using, I'm sorry, what? What's it called?
Web protege. Like a protege is the most. Yeah, protege is the most, I guess, most common tool for ontology.
I'm sorry. You're talking web protege. Okay, so really, you guys went straight for an ontology tool rather than a graph tool. I get it. Yeah, that thing is interesting. I've used protege.
Yeah. So and we actually have a few graph tools that we have, but nobody's actively using them. But hopefully, we'll start doing that more. But yeah, the idea is that so the ground truth of ontology is still in the comma separate in the files, but they're trying to basically build the data flow where people actually use web protege, and when they look at ontology, when they change it, when they fix it, they're actually using web protege. We don't have that working. Like it's work in progress.
Yeah. Yeah. I mean, if you need collaboration on that authority, and then also if you need an API, so basically that's computer collaboration.
Oh yeah. And everybody wants like a Sparkle interface. So yeah.
Really.
you magically can get all the queries answered.
So the funny thing is, Pool Party, the tool we use for managing our taxonomies and mapping our taxonomies, is a triple store based, and it has a SparkQL endpoints as well. Mm-hmm. Then they build an API on top of that to simplify it.
But they actually so it's a very very strict definition of what I'm working on. It's really keys to the database. that I'm working on. But we're actually trying to build like a more smaller, more generic ontology or knowledge base where we actually can use it for search. They can use it for other things. Like what we found is that like other large organizations that provide data, for none of them really use. And if they have like knowledge base and ontology, it always diverges from their definitions of the databases. Just because I guess to use the tools, they really don't want. They really don't need the precision that you need for databases when you're defining different entities. So.
Yeah, I mean, your main use case really is a data integration one.
Yeah.
Right? And you need a lot of precision for that, and that's different than the knowledge uses or retrieval usage.
But I'm actually like I think I'll try to show one of the tasks I'm working on today, because I think we talked about basically annotating text with our ontology. So I started doing that last night finally. So I wanted to like show maybe something.
Ah, there you go. So you're crossing the line from the data. Crossing the line into the knowledge retrieval world. Okay. All right. Well, that's great, Yuri. Thanks for the. We'd love to see stuff. Let's have Sujit. Let's complete the circle here, here, and have Sujit do a brief introduction. You may also want to talk about clips, just because.
Yeah, we can do that. Yeah.
Go ahead. Go for it.
I work for Elsevier Labs, and Elsevier, I don't know if you know it. We are a pretty large academic publisher. I think the largest in the world. So I'm part of labs, and some of the time we do kind of applied research, mostly in NLP. I have worked in computer vision as well, same company, for images, right? So, but mostly our focus is on NLP. And we also get farmed out to other groups for helping them out with specific things. So currently I'm doing, I'm parsing JSON. So, but it has promise. Obviously, there is entity extraction and relation extraction. Currently, they are rule-based and dictionary-based, or dictionary-based and rule-based, respectively. And hopefully, we'll make some progress, and we'll be able to move to machine learning-based things for those. I'm also, because I kind of inherited this whole pipeline. And I'm running this pipeline. It's, I don't like what I see. So I'm doing some mostly architectural suggestions, proposals. It's kind of a, we are kind of a very, what's it called? Consensus based. So if we have to make a change, we have to basically talk about it and, get everybody's approval and then move forward. So I'm writing a proposal. So that's, kind of what I do. It can vary basically. Sometimes it's like really cool stuff, and sometimes it's really boring stuff. Yeah. So right now I'm in the boring stuff phase. So because I was bored, I also well, not because I was bored. So there's a bunch of guys at this TWIML. So we are part of another study group, right? The DL PyTorch. So I don't know if you know people there, but Mayank is pretty famous there. So so he came back and suggested that, like he found this Hugging Face event. Should I go now or should I go later?
There? Yeah, you're talking about the
clip,
group on TWIML. You were talking about the group on TWIML Pi.
Right.
What is it?
DL PyTorch. And this will lead into the clip thing. Do you want that later, or do you want it? I can finish it off now.
No, go for it.
Okay, cool. So so basically, so he came in with this Hugging Face event, and so a bunch of us signed up, and we initially wanted to. So one of our, so there is another study group that I'm part of, which is the unsupervised learning event. So there we are supposed to do a project, and I suggested something called Convert. It's basically using contrastive learning for images and captions to bring, basically, project them in the same space, but using contrastive learning. So it's kind of unsupervised, because you're basically saying that, like this image and this caption belongs together, therefore they should be close together and so on. So I had read this paper and I wanted to, basically implement it. And so I was talking to one other person there, and he came back with a better alternative for this, for our work. He found a transformer-based model called CLIP, and it was from Allen AI. And so he suggested using that to do the exact same thing that suggested with Convert. So basically take medical images and fortunately or unfortunately, that idea was already taken. By the time we got to presenting our idea at this Hugging Face event, somebody else has already said that we are using CLIP and we are using it fine-tuned medical images on CLIP. So we said, okay, let's do the next best thing. So we went around looking for data sets, and we found this remote surveillance thing. And luckily for us, or unluckily for us, we got better results than the medical people, and we placed third in this event. So essentially it was, so the event was about Jackson Flex. So those are like, just like PyTorch and Keras and TensorFlow. This is another, library. The only big difference is it's fully functional and it's XLA compliant. So it compiles down. So all your code, you can JIT compile it down to XLA. And XLA is what TPU uses. TPUs understand XLA basically. So, and it has a number of primitives by which you can take your code and physically farm it out to different devices, right? So that was, that was the event. That was what it was all about, and we are all supposed to do stuff, create things based on Jackson Flex. So most of the Jackson Flex work was done by Arto, the other guy I was talking about. But I did get to see a little bit, and there was talks and so on. So I was quite impressed with Jackson Flex too. So yeah, so that's basically the story.
Right. But sort of to give a little context to the story, you ended up with a demo, and what that demo showed, that Streamlit demo, was that you could put in words, right?
Yes.
And get back images without. So basically, it's an unsupervised approach to multimodal classification, sort of.
Yeah.
Multimodal retrieval.
Yeah.
You don't have a training, really, right?
Exactly. There is no training. Well, in this case, the only training signal I'm giving it is that an image is associated with a caption, right? Yeah. So that it's, well, this image and the caption pair are found in the wild. So in that sense, it's self-supervised. Basically the use case that we were trying to push here is basically text to image search, right? So you type in a bit of text and you get images that look, that describe, or that are described by the text that you typed in, or image to image where you do straight image similarity, right? So, and we also came up with a new use case where, this is basically, of probable interest to, people like who are doing surveillance or any occupation that has to deal with, large volumes of images and find little things in them. So essentially we said that you name a feature and we will look for it in the image and we will isolate it, right? So in our case, let's say you're looking at an aerial picture of some kind of seashore, right? And you can say, okay, find me beaches, or find me, highways, or find me cars. And it will go and look, it will basically chop up the image in little pieces and, send them all to this model and bring back the ones with higher probability, right? So that was the third use case that we did in our demo.
So it treats an image as a point, or does it also understand superpixels within an image? Does it understand an image map also, or does it treat images as a point, basically?
It treats images as a point in this embedding space. And this basically this point in embedded space, the captions are also a point in this embedded space. Right, so it's a shared encoding.
It's multimodal for sure, because it puts both into the same embedding space. The captions.
Interesting. Very cool.
But how does it? Yeah, and then but somehow it also associates not just the point, or did you split up the? Basically, you guys split up the images into their different sections.
Yeah.
To
So
get to the point.
yeah. So essentially, what we did was you give us a big image, right? Some kind of satellite image, and you give us what you want to look for. And we chop up the image into a certain number of slices. So in my case, I was I was being lazy or being practical, however you want to put it, and I would cut it up into say 12 basically pieces, right? And I would send a batch of those 12 pieces into the model, and along with the caption, right? And it would come back and tell me Clip has an API which allows you to say, give it multiple images and one caption, or one caption and one image and multiple captions, right? And it would give you a rank based on that, how good the captions are to the image, right? So we basically use that, and you get back the little patches that we cut up in ranked order, right, of probability.
Interesting. This is somewhat similar to the Recaptcha task that humans solve, right? Like you are shown a grid of a single image is cut up into a grid, and you are asked to click on all those pieces which contain a bus or which contain okay, that kind of a task.
Right.
Okay.
Exactly.
By the way, I've been putting some links in. There's the clip link right there. Also, do you have any, Pushkar, do you have any potential use cases in mind for multimodal NLP?
None as such, but sometimes what I have seen is that when dealing with like product data, let us say you're dealing with some kind of an e-commerce product data, then often you will have both text information about a product as well as image information. However, the coverage in each of these cases will not be 100%. You will have only like 60% products covered by images, and maybe something like 70-80% covered by text. And maybe you will have some products which are in the intersection which have both image as well as text. So if you could somehow use multimodal learning, then you could rescue those products for which you only have image or you only have text. Then basically, I was just thinking whether this technique can be somehow leveraged there.
Are you talking about to help retrieval, information retrieval, search?
Yeah, information retrieval could.
Yep.
Yeah.
Did you have information to improve information retrieval in mind, or do you want to generate captions for the ones that don't have captions?
Oh, okay. Yeah, purely information retrieval kind of use cases. Yes, not.
Yeah, I'd have to say now, Suji will know more than me, but I'd have to say that clip model is it's almost perfect for that, because as long as you have enough data in your domain, enough images that have captions, then it makes everything retrieval, whether they have captions or not, for sure. It's almost a no-brainer in terms of whether it could work in your use case. Right,
it's a basic, so like I said, the text to image and image to image, those were like our basic use cases that we went in with, right? And it's, straight up information retrieval.
Yeah, I will definitely look into this. This is interesting.
That would increase your recall. I have a crazy idea, though, which is that actually, if I was, instead of looking for a product, or maybe I'm looking within a subset of products, but I could look for a particular feature. So it's not going to be a port, but it might be a, I don't know, like there's certain, parts of or aspects of products that I want to search for. Like, I don't know, I can't think off the top of my head, but you know what I mean? Like color, or not color, but really sections, like I can't think of it. I know there's something there where you could do sub-image searching, basically, across your product base to find every product that has a certain aspect to it.
Right. Yeah, I was actually, so for medical images, I was thinking in terms of, if you do microscopy and you can find tumor cells, right, by how they stain, right, or, the sizes compared to their neighbors and so forth. So things like that, I mean, those are kind of features, but, if you train it well enough, like I would think that, if you were training it with, say, microscopy images with, disease cells versus healthy cells, and you had enough of those, you should be able to identify it with some kind of clip-like model or fine-tuned clip, or fractures or, pleural effusions in your lungs and so forth, right? So.
Yeah, I mean, it's interesting, right? When multimodal first came around, the first idea, thought, at least in my mind, was, oh, you could do one search across all the different types,
yes,
right, of content, images, voice. But now that it's matured a bit, and like you're deep in the weeds, right, Suji, and we're sort of following along with you, it's much richer than that, right?
Mm-hmm. Yeah.
The value of it, and it's.
Yeah, and if you think of multimodal in general, like, even for consumer applications, right, Spotify, you can describe what you want, right, and it will find you music that, fits your description. And it doesn't have to be just like, rock and jazz or whatever. It could be like long things, right?
Right. Huh.
There was a Kaggle competition recently. I think a bunch of people thought of like participating, and I also it looked interesting. It was right around when After Clip came out.
Mm-hmm.
It was both. It was product matching.
I see. Okay.
And it had description of the product, but it also had text right on the product.
Cool. Yeah.
All right, guys. Is there anything anyone wants to? Should we go in our circle and see if there's anything anyone else wants to bring up?
Yuri wanted to show that thing, right?
Right.
Oh yeah.
You want to do that now, Yuri? Is that all right?
Sure. Actually, I have a quick question for Sujit. I don't know if are you guys going to continue? One thing I thought of, like, would be interesting. But this is I'm looking at this from like my use case.
Mm-hmm.
So right now you have satellite images and you have text.
Mm-hmm. Good.
What would be interesting, because people don't know how things look from above, and especially that's true for agriculture, right? Yeah.
Mm-hmm. Yeah.
I can look at the corn or soybean field and I can't tell the difference.
Right.
But
right.
from the so how people actually do ground truth is either farmer knows what he planted or somebody like drives by and takes a picture.
I see. Okay.
And they actually in a lot of countries they actually do those what's the word, like basically people it's a crowdsourcing projects where people like take pictures, and then each phone has a GPS, so you actually collect some ground truth.
Mm-hmm. Okay.
But in general, I think it would be interesting to mix together with satellite images, mix together another type of image, right? Translate the picture from like a street level,
right, yeah,
picture of satellite. And street level pictures actually I think people have been doing that possibly. You can actually do Google Street View. You can get
right, yeah,
street level pictures.
Yeah.
So
Yeah, yeah. So we might get additional support. So that's a really cool idea. I can, we are inviting you to talk to us anyway. I think it will be not this week, as far as I can tell. Because only 3 people have, so we are doing a when to meet, so you can figure out who's available when. And so far, only 3 people have put in their availabilities. So I don't think it'll happen this week, but I think there's one of the other guys. Has exams, and so he gets free next week as well. So I think it'll be sometime next week. But you can definitely suggest, and I can suggest also. This is a cool idea. So the status so far is that they are going to give us additional TPU time, and depending on how cool our idea sounds to them, the level of support will vary basically, right? So I think there is some, I don't know if there is interest in monetizing it, but from the judges, at least one of them said, like, I can see it becoming a finished product and so on, right? So there might be some interest in monetizing it. So I mean, so far we have our only suggestions are like more data. So we are planning to use the functional map of the world that you sent, you suggested. Also the Kaggle computation that you pointed out. So there is the XView one, which is the top down. So they have images.
Oh, the original, the first. Okay, yeah, the nadir pictures, right?
Yes.
Or Zenith pictures.
Right. So we might pull in those. What else was there? There was some other suggestions that were there, but this was the major one, right? So like add more data and make it more robust. But this is a cool idea. I mean, change the direction a little bit and say that we want to train on both kinds of images, and and that will be something new too. Right?
But it's like almost separate source. It's like text or street level pictures is really. And the satellite picture have 3 independent sort of representations.
So wouldn't you need captions in your street level pictures?
Yeah, I think what we so currently you can map 2 pieces of information right together in this contrastive learning thing. So what we might need to do is associate the same caption to both the street level and the.
You can so you infer it. You just infer it over.
Yes.
And so your main thought is that, we'll be able to search on a word and get back both types of images?
Yeah.
That your main?
Go either way, right? Like maybe.
So you can go street level to satellite to street level, caption to street level, all directions. Talking of that. So the other direction we were talking about, this is Arto's pet project. Basically he wants given an image, he wants to be able to generate captions, right? So we were so he actually started working on this, but he didn't have time to finish or get reasonably good results at that point because of time constraints. So essentially he hooked up a clip encoder, a caption encoder, to a GPT-2 or I think GPT-2 decoder, right? And but the results were not very good. So yeah.
Use GPT-3.
Yeah, but I don't actually know if GPT-3 is available, right? Is it? If it is, then he used GPT-3.
Of course, what would be very interesting, because generative stuff just doesn't, it's not reliable, it's creative, right? For the most part. So what I would say is interesting, because you could actually take images and in the clip model and get it's kind of like a re-ranking exercise. You could get like 20 ranked by likelihood and take their captions, right? And then so you've got an image, you search on that image in the clip embedding space, you get back a bunch of images that have, and filter for just with clips. Take the top so many, not clips, I mean with words, and then captions, and then you could take that combined with your generative model to guide the generative model. So you could basically create that, or you could simply take the caption that's there and do a data augmentation thing, although who knows what you'd get out of it. But
yeah, so we went with data augmentation, and this was Gautam used to be in this channel as well. So he did most of the work on that. So we used back translation, right? So we didn't do it as aggressively as we did it with images. So we found that of the 10,000 or so images we used to train, images had an average of about 5 captions each, right? Some images had 2 or 3, so we kind of backfilled them with these back translated versions, right? So everybody had the same number of captions. So yeah, but that was a cool, and we actually got pretty good results with that too. I mean, the back translated ones were not too bad, you know.
By back translated, you mean you go from text to image and then back?
No. So we go from English to Russian and back, English to French and back, English to Arabic and back, that sort of thing.
Okay, still within the text space itself.
Yes,
Okay,
yes.
got it.
Yeah, it's just a way of, well, you can use it as a way of generating more data for your supervised learning model, right? To make it more robust.
Mm-hmm. Yeah.
Kind of like, it's great because it takes advantage of what can be weaknesses of probabilistic models, right? And then that's one area where that back translation is used, right?
Right.
Were you going to say something, Suji?
Mm-hmm. Yeah. No, sorry, I was agreeing with you. Yeah. No,
Yeah, I mean, it's probably a better solution than a lot of the data augmentation where you use you replace entities with other entities in the phrase, or you replace similar, the same type of entities, like one company with another, or you replace with a thesaurus, right? You replace words with other words, but back translation seems a lot more organic to me.
Yeah, although, I mean, there is a paper on tortured phrases that recently came out. So apparently Chinese paper mills are taking raw Chinese text and translating them to English and creating junk papers. So, I mean, there is that, it may not be as good as, yeah.
Well, for training purposes, rather than a human reading it, back translation probably helps with your distribution of your classified, your classifier that you train.
Right. Yeah.
That's where it mostly. That's data augmentation.
Mm-hmm. Yeah. Yeah. Probably not suitable yet for human consumption, but. Yeah.
Okay, so Yuri, do you have any more questions or anything, or do you want to show us some stuff or not?
Oh yeah. Hold on. All right, I'm gonna be doing what I was told to never do, is edit code live.
Oh yeah.
Can you see it?
No, yet. Now you can. Yeah.
There you go. We always share code live, dude. Come on. That's like how this came about, practically, this group.
Yeah.
Oh, now I see it myself on the other device. All right.
Oh man, you gotta move to lab. Are you in Jupyter Lab or Notebook?
Yeah, this looks like Notebook, but I like it though. I mean, yeah. Lab's nice too. I mean, got some additional features.
Yeah, Lab has got those things integrated with it, right? Sorry, go on, Yuri.
Yeah, it's got a your command line. You can open a command line right there, and you could do Windows side by side. So you can, starting a new notebook, you can drag and drop stuff from other notebooks. But whatever, it doesn't matter.
So we talked about actually. I'll open the original. So this is kind of work in progress, and yeah, don't post this part of the the video.
By the way, that story is very real one out here right now.
I see. Okay, heat wave. Yeah.
Oh yeah. So yeah, I think it's like the latest. Yeah. So we have a content that we publish, and so this is one of the latest presentations, right? And so we actually like they publish something. It's like a useful analyst statement. You know, people who do trading, people who are basically customers like look at this. And what we do is we actually show displays, and then we'll link a lot of information in our system. But this is done. You know, so when you see highlights, those are displays. I just don't want to like click on them right now. But that's done manually, and that highlights, you know, the capabilities of growth. So what we'd want to do is we'd want to annotate those insights with the data that we have. So basically, if we're talking about something, let's basically find all the entities that we're mentioning here. For several reasons, you can actually, you know, create links automatically potentially, or you can use it in search. Like now we know that, you know, if you can see those like blueberries, that we probably have them like as a separate entity. So if somebody looking for blueberries and specifically searches for those blueberries, we probably want to tag this. Yeah, like a general search may help, but maybe like specifically that could be like a keyword that they specifically like document is tagged with. So the task is like pretty nebulous. Basically, tag this any text with our existing ontology. So this is just a first kind of. I started looking at it, so Spacey has like a lot of different. So I want to try to do it in Spacey just because they already integrate a lot of stuff. The first I'm just showing Spacey name, like a default name entity recognition, and it's actually, you can see this is like a small. I'm working with small set. Depending on whether it's small or large, answer changes actually. And
so
the default, yeah, go ahead.
So what I see in there is really interesting is like high bush blueberries, right?
Yeah, so you can actually see. Oh, so
no, that would be interesting to link to and go to that data set. Does Spacey get that one?
Let me show. It gets it in large, but it gets it incorrectly.
Oh, okay.
It thinks it's a person by bush.
Yep. But to you, it doesn't matter that much because you could actually.
No, this is
well.
Yeah, I'm gonna like do my own matching, but I just wanted to see what just name entity. So I actually started looking. So I think Sujit posted the person doing entity linking in Danish some time ago. I think she's actually working for Spacey, so she did a video. There's a separate video, like a more like a. She refers to her like presentation, but she has a more instructional video how to do knowledge base in Spacey. So that's what ultimately I want to try. Part of this video is how to do it in how to label things with Protege, because they want to sell Protege. But there's a cool way to build a knowledge base and do vectors, and vectors are like basically average of phrases. And they concentrate on disambiguation, but I think the same thing I can use same thing for tagging. But like right now I wanted to like try a couple of like more basic stuff approaches. So name entity recognition, I just want to run and I wanted to use Displacey, which is what this is.
Mm-hmm.
I mean, you could practically use your ontology name variants in there for
Yep, that's the next step.
node, and then just match phrase matching and then linking.
Yep, that's
Because
the
you have
next
such a
step.
good ontology. So in other words, that whole biocorsic stuff or whatever it was, or the lexical matching, like that's one place to start because you have the lexicon.
I think that's
and
what
in
he's
fact,
done.
when I do my keyword extraction stuff, I do lexical extraction using our dictionary called What Is. That's TechTarget produces that, and I had to massage it quite a bit, but then I also use Spacey. I mean, I treat it all as keywords, but anyway.
Yeah, phrase matcher. That's the one. Yeah.
Yeah. So I started with phrase matcher. So I want to like experiment with it a little bit, and maybe we'll try to do.
Well, that's a NLP. Oh, I mean, I'm sorry, that's Spacey. Got it.
Yeah.
Spacey phrase. And I was thinking maybe I'll try like do fuzzy wuzzy matching next, just to see if it will give me like a good matching. And
how many
yeah, so
documents do you think? How many documents you have to do this again? I bet it's a pretty small collection, a couple thousand.
It's like a 500 maybe.
Yeah, it's like nothing.
Yeah. And we can
hire someone to do. Just hire someone to do it. I got someone who does it cheap.
No. But the idea is that once we learn it, we can we don't have to tag our documents. We can tag any agriculture related documents.
Yeah, no, I could see that that's absolutely perfect for your business model, because your business model really is one of not only having your own knowledge graph, but your knowledge graph is about collecting data from all of their sources, right?
Yeah.
And then even semantic web, perhaps bringing in public data through the semantic web stuff. So this is a great way to get started in linking your data right into content, because once you do it locally on a small scale, world is kind of important to you guys, because you get data from not only your data providers but the web.
Mm-hmm. Yeah. There's one more. Okay, I'll let you go through it first.
Oh no, go ahead. Because yeah, I just wanted to.
Okay.
I'm almost done. I wanted to
okay.
do that next page.
So one way that just occurred to me right now is that let's say you want synonyms of blueberries, right? You could look up Word2Vec and try to rank them by edit distance, right? So that you don't get strange like strawberries or something, right? So you might get those. The other way to get this is go a totally different direction, non-spacey. There's something called autophrase, right? You can basically it's unsupervised, and it learns to basically find keywords or phrases in your corpus based on frequencies and such. But you can seed it with your own vocabulary, right? And so it uses that to learn better vocabularies. I've used it in totally untrained setup. Well, I have not used it. I got output from someone else who used it totally untrained. And then we tried to find things that were of interest to us, not covered in our taxonomy, but additional things that might be of interest to us to look at. So this might be a way to grow your ontology as well, if you want to take a look at autophrase.
What is
autophrase? Let me see if I can find it, and I'll send you the link.
And I'm curious.
Oh, you have it?
Okay. You mentioned synonyms.
There, that's one. That's one. Yeah. Synonyms of blueberries I don't know. Blueberries may not have synonyms.
Yeah,
right?
but let's say corn is maize, right? That's most famous synonym we have. But how does it help with synonyms?
It would find, so if you look at neighbors, it would find things that are related to it, right?
Okay.
So, who had come in similar context, right? So blueberries might actually come with strawberries and other berries that live in the same kind of, same recipes or whatever, right? So, yeah.
I actually have an opposite problem. So we know the synonyms, right? Because we already, we have list of aliases, because, so if you search for maize, you'll find corn in our databases.
Okay. But is that complete?
Not necessarily, but I think those I wouldn't want to like create them mathematically. Actually,
Okay.
my problem is the opposite. I want to bring core, like not for this, probably. I'm not sure if I'll need it for this, but like for my mapping, I would want to train my embeddings to bring corn and maize closer together.
I see. Okay.
So I haven't done that. Actually, that's one of the things, next things I want to do on the mapping project.
Okay.
So you mean using synonyms that are in your ontology to adjust the embedding space?
Yeah. So like basically right now, when we're using our embeddings, we rely on the general language model, knowing that those things are synonyms, and they should be close in the general embedding space. But we'd want to push them closer.
So let me ask you something about your embedding space. Is this an embedding space of the items that are in the embedding space? Those are your ontology entities? Or
Yeah.
are you talking about some, okay, so you have an ontology embedding space and you want to help use your ontology information. So how do you get to your ontology embedding space? Or you're not using like Sage or Graph, right? Yeah, right. What are you using to generate that?
Okay, but what's it?
Well, for example, if you had this thing in a graph, right? I know how you do it. You use SageGraph or something to turn your graph into an embedding space. It's sparse data, whatever. But I don't think you're doing that. So you must have some sort of things that represent each entity, documents,
Yeah.
data, or something.
So right now it's pure NLP. I actually like so right now my embeddings are pure NLP phrase embeddings, and we have two ways of doing it. One is just like average of bird tokens in the phrase, and then the second way is whatever the whatever the method sentence transformers are using. So it's I think they have like
I'm with you. So basically, but where do you get the phrases from? So you have an ontology with synonyms. How do you get reliable phrases?
Oh, yeah, they are phrases. So they are. So you can see fruit crop, like here on the fruit crops is part of.
I still don't see how you can get but usually for each. So you're just making an embedding space of phrases. So it's really just like it's like word to vec. It's a word phrase.
It's an average. Well, we can think of it as just the simplest is the average of between all the words in there.
Okay.
But they're bird, so they know the order somewhat, and like negatives.
So you're trying to inject. You're trying to prejudice your model in a positive way by injecting your knowledge from your knowledge graph, and specifically.
And also what we do now is, so we don't use graph embeddings, although like I want to try to do it, but we modify our embeddings based on our graph structure. So we have NLP embeddings, but we modify them based on, we push basically what we do is push parents closer to children.
So that's cool.
So blueberries will be closer to wild blueberries and
there's still a fundamental thing There's still a fundamental thing I don't understand about your base, because if a knowledge graph has 10,000 terms, right? Let's just say there's 1,000 concepts, or let's just say there's 1,000 concepts in it, and they have synonyms, so you end up with 10,000. That's like, normally when you train an embedding, you're using sentences that have those words relationship to each other and lots of sentences, right? So the model can distinguish what's similar and what isn't. But like, that's really sparse data. I don't quite understand how you can make an effective embedding space when you don't have the sequences with the words in different contexts and stuff.
Well, some of them are quite, you don't see those here. But some of them are quite complex. Because we're trying to, this is just a phrase match, so that text didn't really talk about, packaging, didn't talk about, conditions. things like that. So that's why you don't see it in the match. But yeah, we have like a our entities are
normally I would expect, like, to represent fruit crops, you probably want to have like 100 sentences.
Yeah, so that's an item that was added somewhat recently. So soybeans
okay.
destroyed under federal or state order.
Oh, I'm sorry. So that is sentence for that
yeah, so
ontological term. So you do have
yeah,
sequences for sentences with context.
Yeah, so this is the yeah, so that's the entity basically. So we have data published for this entity.
So wait. So 2906 is your ID, or 17930. So this row.
No, that's just the second one is ID. First one is just enumeration.
So this is actually the data you have for that specific.
Oh no, there's no data. Like this is just items. So it's gonna combine with the metric, which I'm guessing this is some sort of crop insurance metric. And then you pick a region of where you want to look at, and we'll have data for like those three things.
There was some. I think what you just demonstrated to us was how you're moving from the world of database mapping, where you're mapping your columns. You're doing that to this connecting it to content itself, and in this case.
Like you're dropping off.
Okay.
So and it's a.
Okay. Was there anything else you wanted to show?
No, I just want to like kind of show like what I'm. So I'm gonna try to I'm gonna look at auto phrase, but basically next thing I want to try here is to like try the knowledge base that comes with Spacey, just to see how it performs. Oh, and then the other thing is, so I don't know if you guys seen this, but Spacey has this. Basically, they create classes for that dashboard, like the dashboard tool that you guys used. Like, give the name escapes me.
Streamlit.
Yep, Streamlit. So
yeah.
So Spacey now has classes for Streamlit, so you can basically from here you can create Streamlit. Like you don't need to write code because they already have everything. I haven't done that yet, but
I have used it for I have used it for dependency parsing output. So I wanted to show people, basically I wanted to have people enter their own sentences and get dependency parse output from 3 different models and compare them side by side. So that's I used it for that. They also have, so I had to push it through, what's his name, the reverse proxy, Nginx, right? And they have pretty involved parameters for that, because it passes in, a lot of stuff, right? It's just not, it's not just an HTML output. It's got like a lot of these other things going on. So they have, it's somewhere there. I can, so in case you get, you have to send it through Nginx, let me know. I'll send you the entire block. So, it's they're really simple. I copied it from somewhere.
Cool. Yeah, that's thank you. That's it.
Yeah, this actually, thank you though. This actually gives me an idea for the stuff I'm doing now. We are actively looking for a successor to the current entity annotation tool that we are using. And, the entity annotation tool that we have right now does a lot of stuff, but the basic matching, it does it a little differently than just linear. And I have a theory that, just streaming through the text using this sort of thing would actually be helpful. So I can put them side by side now. So I had forgotten about the phrase matcher, but using the phrase matcher is nice and neat. People tend to get a little antsy when I say ahokorasic and then do this and do that. But spacey is nice. It hides all that stuff. I can call a phrase matcher with a list, and I'm all set, right? So I'll try that out. It's actually a good idea. I can use this for something.
Cool.
All right. All right.
Yeah.
Suji, was there, I guess, Suji, is there anything you wanted to bring up that we could probably talk about that graph stuff forever, but is there anything you wanted to bring up today that we haven't discussed?
Not right now. I came across, so now I'm doing, architectural kind of things, right? So I came across architectural approach called C4, right? So this guy advocates, no diagramming standards, it's just boxes and arrows, but you have 4 different levels, right? So C1 is like system level, you just talk about what the system is and who the clients are. C2 is, I think, container, yes. So you talk about the inputs and outputs of the system. And C3 is actually, the components of the system. And C4 is the class level, So that was actually quite interesting. So I'm using that to do my proposal. So I learned C4 over last week. So yeah.
Nice.
Yeah, Brat, by the way, Pushkar is one of our teams uses it for manual annotation. So we get automated annotations and documents, and we publish Brat documents, and then they go in and manually change or highlight things that they want and remove things that they don't. Right. So yeah.
Oh, cool.
Yeah.
Nice. It's a nice tool.
It is a nice tool. Yes.
I had used it for that addresses data project that I spoke about.
Okay.
Makes me think of the old days of Gate. Remember that?
Well, Gate had everything, right?
Yeah.
Except it was horrendously difficult to use.
The old days of Java too.
Mm-hmm.
Not that those days are gone, but harder to deal with.
I use UML quite a lot.
GML? What's that?
UML.
UML. Okay. All right. Okay.
Yeah, for software design, you're talking about.
Yeah, well, people use it for everything, for like system design also.
Okay. Interesting. I had a call with Pinecone. You guys know who they are?
I think so. They're the vector people, right? Vector search.
Yeah. Exactly.
Okay, yeah.
And I know a lot about vector search because of you guys, particularly. They just randomly came to me from someone else in the company, but I had a call with them, and they're very focused. It's vector search, and so then I also tried out I've read their API documents and everything, learned about their pricing, and it just seems like a really good similarity engine, basically, right? Sort of modern similarity engine, and they have like these notebooks of use cases. They have extreme classification. They actually had one. Like this. They actually had one where they use it for deduplication. Because I had that deduplication problem I was trying to solve with web pages coming into us, and we needed to deduplicate them. And local semantic hashing (LSH).
Okay, right,
I know that Suji, you turned me on to that, and I used it, but it was too complicated, difficult for us to implement actually in a way. And so what I ended up doing is using something. However, what they do that makes it scalable is they have this use case in this notebook where you basically, you have your database, you have your, vector space of all of your documents, and you do a vector space search on a new document that comes in, a new web page, right? And it gives you like the top 100 results. and then you basically run your local semantic hashing on those top 100. It's pretty straightforward, right? And it makes both that and the local semantic hashing quite scalable. And then you get your rankings back from your local semantic hashing, and you could figure out, a cutoff, and those are your duplicates.
Cool. Yeah.
So it's interesting to see how vector search is turning what the use cases that, at least they're kind of in early days, but what use cases they're trying to sell with vectors. One of them is the deduplication. Another one is extreme classification, they call it. And another one, so you just basically similarity-based classification. So it's like your ontology, or you put in your taxonomy of topics. Train, for your vectors, each item in your vector is an ontology term, a taxonomy term.
Do they do strict vectors, or they combine like vectors and like other searches, like
they have parametric.
25?
Well, so I'm not totally sure. I know one thing they do have is in their APIs they have parametrics, so you can also, of course, search, get results, and filter them down by parametrics. But also they do something to make it scalable, where you lose a certain amount of precision, and they have this benchmark notebook where you use standard search, keyword search. It benchmarks those results against your vector search results, and so that you could see how you could keep an eye on your model also to see how it evolves over time if you get a bigger gap between those two or something. But I don't know if that keyword search, if you're talking about mixing keyword and vector search, I'm not sure if that was possible. Is that what you're thinking, or what are you asking?
Because I think that's what. So we're trying to like integrate vector search, but I think the way I understand people are using it, they basically combine sort of vector search results with the traditional like BM25 or some modifications of that. So vector similarity is like one input, and then people kind of and then you sort of like mix and match the scores from different mappings. But I don't know much about it, because we haven't done it yet.
Yeah, you might be able to do that. I don't know. I didn't get that deep.
That's one way of doing it. I mean, there is also the two-phase thing where you get a lot of, you use a Lucene index to get a bunch of results, and then you do vector re-ranking on that.
Yeah, I mean, but that restricts you. I mean, of course. But concept search is nice, right? Where you're searching,
Yeah.
depending on your use case.
Yep.
And you could basically, it's interesting because it's like a lot of this stuff, like when we did the ULM fit or whatever that was, the clustering. I mean, basically, you can put any embeddings you want, just like you did, Suji, right?
Yeah.
You can represent however you want. But anyway, I'm actually I think I'm going to start trialing it in a little while. How it goes.
They are a SaaS-based thing, right? I mean, do you?
Yeah.
Yeah. Okay. Yeah.
So that's the point. They're completely managed service, right?
Okay.
Right? We don't have a team. If we're going to move forward at a reasonable rate with NLP, somehow we need to move ourselves into the world of managed search. I mean, managed stuff when it's appropriate. That's my feeling. No one's told me that at work, right? But so it's a completely managed service. So it's crazy, super easy to use. And interesting, their pricing is based on gigabytes of RAM per second.
Okay.
So they have a pricing chart that shows you if you have this many documents and you represent them with 500 dimensions, most likely you'll have to pay 0.0001 per second because you'll need this much gigabytes. And that means that basically I calculated it out. So if I have 1 million items or documents in a collection with 500 million or less with 500, dimensions, it'll cost me around $2,000 a year,
Oh,
maybe
okay.
$3,000.
Okay, that's very affordable. Yeah.
Yeah, it kind of ramps up. It gets kind of steep when you get bigger, right, into the tens and hundreds of thousands. But
Right.
if you're just going to do a couple of medium-sized, like first of all, for proof of concepts, you can do them and then tear them down. But if you actually go into production with 200,000 or 300,000 or under 1 million collections, this is not too bad.
Right. Yeah.
For such a nice technology. I mean, it's open source options, but
So do you have to push your data and have it indexed onto their remote instances, or does it also have any federated option where data stays on your side, but the algorithm comes to you?
did mention that they can do that, where you can do it on-prem. Or also they can isolate you more explicitly from the other
Gotcha.
environments. So they're definitely, obviously, they want to be able to sell to companies that have sensitive data. Now, how they price that and how they accommodate that, I didn't go too much into that.
Nice. Have you also come across this Facebook FAISS?
Yeah.
So by the
library?
way, there's two different engines you can use with Pinecone, and that's one of them. The other one is an ANN one, or something. Maybe they're both ANN.
Okay.
But they're actually using that as an engine, I guess. So absolutely, that's the scalable. And Google has the same thing they have, because they were the ones who, I think, pioneered this, but they have something, they call it Vertex Matching Engine now. It used to just be the matching engine. Who knows what it was before that. It's kind of complicated to use, though. A lot more complicated than this managed service. They have a vector matching engine as well, based on ANN, I guess.
Right. Yeah. I mean, ANN is the thing, right? HNSW. That's your go-to now for a lot of things. Yeah, I haven't used FAISS. I've used its, FAISS works best on a GPU. And I don't, for inference, we don't get to use GPUs that much for cost reasons. So we have used NMSlib. That's actually faster than FAISS on CPU. It's NumPy basically. You put NumPy vectors and it creates a ANN index on top of that and provides you a searchable thing.
How do you spell that? ANS?
NMSlib. Hang on, I'll just put this in here.
Yuji also did some work and a proof of concept, I think, with vector search engine called Vespa.
Vespa, yes. Yeah.
Yep. Like the VESPA, I think.
Mm-hmm. Yeah, Vespa is open source. It's used by Yahoo. They actually have a ANN index in there. It's actually quite good. It's a slightly steep learning curve, but once you get past that, and I can do a shameless plug here. I wrote a blog post on the Vespa site about, if you know Solr, it's really simple to go to Vespa. I drew parallels between Solr and Vespa because that's the way I learned Vespa.
Yeah, do you have a link to that?
I can find it. Hang on. Vespa.
So, any other questions or thoughts or ideas on vector search? So we're kind of running out of time. I just want to bring up one funny little thing. I don't know, has anyone heard of Protobuf? Protobuf, Protobuf?
Yeah.
Google.
So can someone? So I only half understand. So it seems to me like it's a serialization format. It was meant to be fast over the wire, but it seems like can you store a pandas data frame instead of, like, I store most of mine in Parquet? Is that like a substitute for that as well? Or when would you use Protobuf?
I think it's really meant for communicate, because it was basically created when we still had like a big engine, a little engine, and multiple computers, and it was sort of like the efficient on-the-wire protocol. So Google used their own middleware to pass data, I think since then, now they use that format everywhere. So they actually use it. I think TensorFlow uses it as their native
For storage, for their
storage,
models. Yeah.
because
So
it's
you guys,
efficient. Like
you guys don't ever explicitly use protobuf, right? Then for anything.
I
Like,
used
depends on the tool.
we tried using them because and I think in when you build your own sort of message passing, that's always attractive technology to use, because it's very efficient and you know, serializable, and it's, you know, standard, and Google is using it, so hopefully it's not going away.
So from the point of view of a data lake or just an object store in the cloud, there's no reason to move from Avro or Parquet to protobuf. You just wouldn't really do that. It's for data frame storage mainly, large data frames. That's what you use Avro and Parquet. Okay.
Yeah, I don't think so, but I might not know enough, like, because we really tried using them for basically to serializing data and sending them over, like different computers, because that's what we tried to work with all the programs, and that's what they did. So that was a way to emulate what was done before.
All right, guys, I think that's it. We actually went over our time. Sometimes we do 45 minutes, sometimes an hour, sometimes an hour and a half, but I like to stop it at an hour and a half.
Yeah.
Kind of guys are going forever.
I have a quick question, but we don't have to discuss it now. So I don't know if you guys do interviews at your companies. So I haven't done a lot of interviews, so now I need to prepare. I've seen like recently 2 books on ML interviews. I don't know if you guys read them, or I can post them in the Slack.
Yes. Yeah, I haven't done interviews for the last 6 years. So yeah, no, I'm totally out of touch.
Yeah, I haven't done interviews. Yeah.
Oh. Yeah, it looks like you're SOL there, buddy. I mean, I've done a couple, but not for a while, and they were for library people, so they were not very formal.
All right. Cool.
But we're glad to talk about it anyway. You could talk about the ideas and whatever, and then that would be fun.
Right.
All right, guys. We'll talk next week.
Cool. All right.
Thank you.
All right.
All right. Thank you, everyone. Have you talk to you guys next week. Take it easy.
Sure.
Bye.
All right. Cool. All right. Bye.